Show that the functions are inverses of each other. F of x is equal to the square root of x minus 1, where x is greater than 1, and g of x is equal to the square of x plus 1, where x is greater than 0. Well, first of all, recall that two functions are inverses if they undo one another under the operation of composition. So for example, we're given that f of x is the square root of x minus 1, where x is greater than 1. Let's pick a number greater than 1, like the number 2, and we'll apply f to the number 2. To evaluate f of 2, we'll first of all need to take 1 away from 2, and then take the square root of the result. We get the square root of 2 minus 1, which simplifies to 1. So when we apply f to 2, it transforms the number 2 into the number 1. Now we're going to apply g to the number 1. To evaluate g of 1, the first thing we'll need to do is to square 1 and then add 1 to the result. We get the square of 1 plus 1, which is 2. Notice that we got back to the original number that we started with. We applied f to 2 and got the number 1, but then when we applied g to 1, it undid all the steps that f did in the reverse order, and we ended up back at the number 2. So this shows us that g undoes f when x is equal to the number 2. But it's not enough just to show that g undoes f for one value of x. We need to show that g undoes f for any number x that we pick which is greater than 1. So rather than starting off with a particular value of x like 2, we just start off with an arbitrary value of x that is bigger than 1. We get the square root of x minus 1. So now we apply g to the square root of x minus 1, and we check to see if we get back to the original x that we started with. To evaluate g of the square root of x minus 1, the first thing that we'll need to do is to square the input and then add 1. When we square the square root of x minus 1, we get x minus 1. When we add 1 to the result, we get x. We started off with an arbitrary input x, we applied f to it and got an output. We then applied g to the output and we got back to the original value of x that we started with. Therefore, g undoes f. We've shown that g undoes f, but in order to show that the functions are inverses of each other, we also have to show that f undoes g. So let's take a look at g. G of x is the square of x plus 1, where x is greater than 0. Let's pick a value of x greater than 0, like 2. First of all, we'll evaluate g of 2. To evaluate g of 2, we square 2 and then add 1 to the result. We get the square of 2 plus 1, which is 5. Now we apply f to 5. To evaluate f of 5, we first of all need to take away 1 from 5 and then take the square root of the result. We get the square root of 5 minus 1, which is 2. This shows us that f undoes g for a particular value, but we need to show that f undoes g for all values of x that are greater than 0. We first of all get g of x is equal to the square of x plus 1. We now apply f to g and show that we get back to our original input of x. We get the square root of x squared plus 1 minus 1. This simplifies to the square root of x squared. Since x is greater than 0, this simplifies to x. We've now shown that f and g are inverse functions. So in summary, f and g are inverses of each other because 1, g of f of x is equal to x for all x in the domain of f. In other words, g undoes f. That's what we showed in step number 1. And then secondly, we've shown that f of g of x is equal to x for all x in the domain of g. We showed that f undoes g in step number 2.